Okay guys, welcome once more to another video again in my channel. So in today's video we will be looking at the Cameroon GCE Advanced Level Physics 2020 question 7. As we all know, question 7 is mostly talking about data analysis. Okay, so this is an interesting part of the A level physics paper in the advanced level. Okay guys, so I recommend that you subscribe to the channel, like the video and share to your friends. Okay, so today we will be looking at the step-by-step solution of this video. Okay, so you can reach me on the YouTube platform via MDLFA or on WhatsApp via the telephone number displayed to you on your screen. So guys, as I always said, or as I always recommend to my videos, that if you are following me, please, I recommend that you should look for a book and a pen so that you take down relevant point that you find helpful in the video. Okay. All right. So without wasting much of your time, let's dive into it. Okay, guys. So that is the question displayed to you, and we'll be tackling the solution as far as possible. Okay. So the question reads: In an experiment to know how the current I in a circuit comprising a capacitor and a resistor varies with time t, a student obtained the following results. Okay, so it's like a student carried out the experiment and the student obtained the following result as displayed to you on the table. Okay, so the current in the circuit is related to the time by the equation I equal to I naught exponential negative t over beta. Okay, so a part of the question says plot a suitable graph that can be used to determine the values of I naught and beta. Okay, and this part is always 10 marks. Okay, and the B part says use your graph to determine the values of I naught and beta. So that is 8 marks. And the C part, it says what is the significance of beta? Okay guys, so that's the question displayed to you, and these are the values given. Okay, this is the time value, and this is the current value. Okay, so in the A level they mostly give the raw data, so these are raw data. Okay, so these are raw data actually, so you will be the one to get the processed data. Okay, so my advice to this topic is that many students, like, what they find difficult is the part of linearization, for them to linearize so that they can come up with their relevant equation that they can apply, and they process their to have their processed data. And again, the emphasis here go to this part, this C part here, that they will always ask students the physical significance of that quantity. Okay, so I will be solving many of these questions, so I recommend that you should actually subscribe to the channel so that whenever new videos are being uploaded, you find them easily. Okay, all right, so let's dive into the solution. Okay, so this is our equation displayed. Okay, so this is the equation that they gave us in the equation. Okay, this is it here. So we have I equals to I naught exponential negative t over beta. Okay, and all right, so this is where we apply our topic the video I lastly uploaded on indices. Okay, so here, for us to bring down this power, because we cannot manipulate this equation just like with this power here. Okay, so we have to do something. Okay, so what are we going to do now is that we'll just take ln on both sides. Okay, so if we take ln on both sides of the equation, we are going to have ln I being equal to ln I naught exponential negative t on beta. Okay, and then here we are going to apply law of logarithm. Okay, a law of logarithm that if you are actually multiplying two quantities, it means you will use the addition law. Okay, so at the end of the day, if we use the addition law, which states that the log of a to the base b multiplied with c is just equal to the log of a to the base b then plus the log of c to the base b. Okay, so since we are multiplying here, it means we add here. So if you look at things clearly, so here we are actually multiplying, okay, because we are multiplying I naught times e power negative t over beta, okay. So that is it. So if you apply that law, at the end of the day we are going to have ln I being equal to ln I naught plus ln e power negative t over beta, okay. So I've applied the addition law here. Now this is another important law again. Yeah, okay. So if we decide to expand this bracket, right, we are going to we'll have ln e exponential negative t over beta, okay. But we know that ln e is just equal to 1, okay. So at the end of the day, we are going to have ln I being equal to ln I naught plus negative t over beta and then ln e, okay. And we know that our ln e is just equal to 1, okay. So this is it, but ln e is equal to 1, okay. So it therefore means that at the end of the day, this our ln e is going to disappear from here, okay. Since it is 1 multiplied by this negative t over beta is just equals to negative t over beta, okay. So if you look at things clearly, we are going to have ln e being equal to ln I naught minus t over beta, okay. So we can just rearrange this equation from here, okay. So if we rearrange, we are going to have ln I being equal to negative t over beta then plus ln I naught, okay. From here right, from here you can clearly conclude that you are plotting a graph of ln I against t or with slope negative 1 over beta and intercept ln I naught, okay. So that is it. So clearly we have ln I being equal to negative 1 over beta times t. Why did I decide to write this negative t over beta in this form? It's because it is very important, okay. Because we are actually plotting a graph of from the table of values, right. So you see that the table is just time and current, okay. So it's just time and current. So it means that we are actually plotting a graph of ln I against t. So t is actually changing. So t is a variable because it is changing, okay. But y negative 1 over beta is a constant, okay. So it means we are plotting the graph of ln I against t with our slope negative 1 over beta and our intercept ln I naught. So either you write that statement or you use this other format, okay. So we know that the equation of a straight line is y equals to mx plus c, okay. So this is the general equation of a straight line, okay. So it means if we compare this equation with this other one here, this our equation up here, it means that the graph is going to give us a straight line too. That is why we have y equals to mx plus c, where c is a constant and it is actually the y intercept, okay. So here we have c is a constant and our m, which is a gradient, is also a constant, and therefore 1 over beta is actually negative 1 over beta is actually a constant too, okay. So that is it. Either you write it in this format or you explain, as I earlier said, that you are plotting a graph of ln I against t with slope 1 over beta, negative 1 over beta, and intercept ln I naught, okay. So that is it. All right. So if you go in plotting the graph, okay. So the A part says from the equation, plot a suitable graph that can be used to determine the values of I naught and beta, okay, and that is 10 marks. So this part here is very important, okay, because if you lose this 10 marks from here, imagine you linearizing your equation, then you have something else. Just imagine losing this 10 marks, okay. All right. So you can clearly see that we are not plotting a graph of we're not plotting a graph of I naught I against t, but we are plotting a graph of ln I against t. So you cannot use this value here because these are raw data actually, but though t is a raw data, but we are going to use it because um if you look at the linearized form of the equation here, the t is not multiplied with any ln, okay. So that is why we are going to use t like that. But from here we have our ln I, so it means we are going to take the ln of this current here, okay. So it means we are going to have another column, another table again, okay. All right. So let's look at the A part. So the A part let's look at the A part in drawing our graph. All right, so this is our linearized form of the equation, right? So we have lin I being equal to, or plotting the graph of lin I against t with gradient -1 over beta and intercept lin I naught. Okay, so this is these two tables, right? These two vertical columns here. Okay, these are the raw data that were given to us. But now we are going to process this data because we are actually plotting a graph of lin I. Okay, so I means we are going to take lin of all this value here. Okay, but notice that you taking the lin of something means that at the end of the day, the quantity will have no unit. Okay, so if you are taking the log or the lin of a quantity, means that at the end of the day, the quantity is not going to have any units. Okay, that is why if you take lin of I slash or I in microamperes, it means you are not going to have any units. So this ampere disappears. Okay, all right. So what are we going to do here? So this part here is very important because what I did is that I did not convert my current to amperes. So the current is still in microamperes. So the general assignment to this video is that you are going to plot your own graph using the ampere. Okay, so mine I use the microampere, and since I use my ampere, our values might still slightly be different. Yeah, the value might be slightly different. Okay, so the general assignment is that you are going to be plotting your own graph, a graph of lin I against T, where this I here is actually converted to ampere, not microampere. Okay, so how are you going to convert from ampere from microampere to ampere? So it means that this value, right, you are going to take this 46.7. Since it is micro, it means you are going to multiply it by 10 power -6. Okay, that is micro. So you take this 46.7, then multiply it times 10 to the -6. Okay, you do the same here, you have an answer. You do the same here, you have an answer. And then you plot the graph. Okay, all right. That is not really. I will explain that better at the end of the video. Okay, so what I did here is that I took the lin of 46.7. So this is my answer. I took the lin of 38.5. This is my answer, and I do the same right up to the lin of 7.7, and this is my answer. Okay, so that is it. All right, so this is the graph. Okay, I've plotted the graph already. Now this is my skill. I know this is where many students actually have difficulties in deriving their skill. Okay, but actually we are going to explain it. Okay, all right, so let's pay attention here. This is where everyone is being called. Okay, all right, so this is my vertical axis from the values, right? This is my lin I axis. Okay, and this is my time axis. So that is it. And then you notice that the values for the lin I axis ranges from 1.5 right up to 4, but on our table we have from 2 right up to 3.84. So yeah, it depends on you how you'll be taking your own values. So as for me, I took a difference of 0.2. No, let me see. Let me take my calculator and let me see. So what you are going to do now is that, because this is where many students get confused, deriving their skill in the exams, deriving the skill is not really easy. Okay, so what you are going to do in this vertical axis is that, on this vertical axis, sorry, so it means you are going to take the closest number from here. Okay, so this is my starting point. Okay, so I will move one step ahead, okay, or one step up. Then I take that number, which is 2. So you take 2, and then you subtract 1.5 from 2. Okay, so it means 2 minus 1.5, and I have 0.5. Okay, now I have 0.5. It means, and then you can see, let's see if the 0.5 is actually consistent, like is it continuous. So I will take 2.5, then minus the previous value, which is 2. So 2.5 minus 2, so I still have 0.5. So it means that my values, the scale is actually consistent. Okay, now since I have 0.5, right, taking a consecutive difference between the two numbers. Okay, mine is 0.5 according to the graph. Okay, so it means I will take the 0.5 now, I will divide it by the number of intervals between those two points. Okay, let me say my 2 points are 2 and um 1.5, right? And then the difference is 0.5. Now I take the 0.5, I divide it by the number of intervals of these small lines. Okay, so it means I'll count these small lines. Let's count together. So I'm here. So this is 1, this is 2, 3, 4, and 5. Okay, or the number of small boxes. So this is 1 box, 2, 3, 4, and finally 5. So there are 5 small of those boxes. Okay, what I will do now is that I will take them as 0.5, and then I divided by 5. Okay, so it means that one of that my boxes or small line is actually 0.1. Okay, it means this my vertical scale is increasing by 0.1. Okay, all right, so that is it for the vertical axis. So let's go now to the horizontal axis. So actually our values for the horizontal axis, it ranges from 10 to right up to 310. Okay, so I begin from 10 actually, and then I move on right up to 320. Okay, all right, so how am I going to divide it now into these intervals? Okay, so what you do now is I come to my closest value. Right? I'll take 40, which is my nearest axis to the end, to the starting point, my nearest value to the starting point. So I'll take 40. Take a calculator, you take 40 minus 10. So I have 30, right? Now you take a 30 divided by the number of intervals between 10 and 40, which is 5 also. So 30 divided by 5, we have 6. So it means one of my small lines is actually 6 here. Yeah, so it means one of my small lines is 6. Okay. So now another important part again disturbing many students in the A level or even in the ordinary level is that how are you going to expand this range from here to here such that it's actually it resizes this axis without you cheating one of the sides, or let me say you do it such that the points do not exceed half of your graph paper. So what you do is that you come here, you come to your given values, you take these values, this 310, right? You, let me say you put it to 320, and then you go to this value here which is 10, put it to, let me say, 8. Okay, so this is a general procedure. Now you take this highest value, right, which is 320, minus the lowest value, which is 8. Okay, if you have your answer, then you come out to your graph paper. So let me say this is your graph paper, right? So it means if you get the difference between 320 and 8, let me say 320 minus 8, so it is 312. Now this 312, what you do now is that you go now to your graph paper. If it is a horizontal axis, you start counting. So this is my number, this is my starting point. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me say 12. Okay. So it means you take this answer now and then divide it by 12. So you divide it by 12. It means that if we divide that amount by 12, we have 26. So since it is 26, it means that this your axis is actually increasing by 30 because it is 26. 26. You can actually round down or you round up to 30. So it depends on you. So I prefer that you can actually let me say round down. So you see that this graph is not actually up to 18. Okay, it's not up to 18, but the general graph papers are mostly 18. 18 of these lines in the horizontal direction, while in the vertical direction they are mostly 22 or 21 there. Okay, so that is it. I hope it is really clear. All right, so when you are giving your graph paper, you want to plot a graph. So first thing you do is that you first of all rule your line. Okay, so this is my vertical axis. Okay, and then I'll also do that for my horizontal axis, which is my x-axis. or in this case it is my time axis, or say okay. So then the next point, that if you fail to do it, you lost some marks. It is labeling your axis. So for my vertical axis, I have a length of I, okay, and then my horizontal axis, I have t in seconds. So this is my t in seconds, okay. And then what I will do next is that, so these are my points. I've already demarcated them on my graph, okay. So what I will do now is that I will draw my line of best fit, okay. So if I draw my line, at the end of the day, I'm going to have this, okay. So that is my line of best fit, okay. Now you notice that your line of best fit, it must not touch all the points here. Yeah, it must not touch all the points, okay. So yeah, now according to the points, right, I have 3.8, but since 4 is less than 5, I will just have 3.8, okay. And then the same goes here. Here it is 3.65, so to one decimal place will be 3.7. Here it is 3.47, which is 3.5. So I just round up the values and I have this, okay. And then for the other axis the same thing, okay. So I plotted my graph already. Now you notice that from this graph, right, so the time is actually increasing while the the current is decreasing with time, okay. Means as time is increasing, current is decreasing, okay. So that is why it is a negative relationship. One is increasing, the other one is decreasing. That is why we have in a negative slope, because in general in physics, right, if your graph is coming out in this nature, just know it's a negative slope, okay. Because you can never have this graph of this form, then your slope is coming out positive. No, it is actually wrong, okay. All right, another important point. Let me think about it. All right, so the next point is that many students try to, when drawing their line of best fit, right, they try to print it. No, drawing a line of best fit, use a sharp HB pencil, or any pencil. It should be sharp enough, and then you place your ruler, a transparent ruler, okay. Because if you use any other ruler different from a transparent ruler, when drawing this point, right, you might actually miss some of the points. So a transparent ruler will enable you see through them, okay. All right, so what next? And then many students again try to force out values, um to make the line of best fit, right. The line should touch all the points. It's not actually necessary. In fact, the line of best fit must not touch the points, okay. All right, so what next can I emphasize again on this graph? What next? So I think that is all. All right, the next thing, now we are about to calculate our slope, okay. Our slope. All right, so if I draw my slope, okay, so this is my triangle. So important, note that here this triangle, right, it should be big enough here. It should be big enough, okay. Don't go and draw that small thing here, like you want to, or maybe you were joking, or you are joking doing it, okay. All right, so it should be big enough. Then what I will do now is that I'll come here and read this point. It means I'll read this point like this, and then I read it like this, vertically and horizontally, okay. But you notice that reading this point horizontally means we are reading the vertical direction, means the I direction, and reading it vertically, we are reading it in the x direction, or we are reading the x value, okay. All right, so let's go and do that, okay. Let's begin here. So we know that this red line meets this line of best fit here, okay. So it means we are going to extrapolate from here and go down like this. So this is our 250, and we know that one of these small lines here in our horizontal axis is 6, okay. It means that we have 1 2, okay. So it means, since one of these small lines is 6, right, so it means we are going to take 250 plus 6 plus 6 again, okay. So at the end of the day, our this extrapolation will give us 262, okay. Yeah, 6 plus 6 is 12, and then 12 plus this value here is 262, okay. And then again, so this is the x direction, so we are going to read the y direction, okay. So the y direction, we know that one of these are small lines here, is 0.1. So we are going to look how many of them are there. So we have 1 and we have 2 and then 3. So it means we'll take 0.1 times 3. Okay, 0.1 times 3. So if I take my calculator, I take 0.1 times 3, I'm going to have 0.3. Okay, 0.3 then plus 2, I'm going to have 2.3. Why am I adding plus 2? Because I want to move from here right up to here. So I have 0.3 then plus 2, so I have 2.3. Means at the end of the day, this my point here is actually 262 comma 2.3. Okay, now let's move to this other point up here. So we first of all read the x-axis. You all know that. So if we read the x-axis, let's extrapolate and go down. So this is our 40, and we know that one of the small lines is 6. Okay, so it means I have 40 plus 6, 46, and then 46 again. 40. Okay, now there's an important point here. You notice that this my line is in between these two lines. So it depends on you. You can either choose this one or you choose this other one here. So it depends on you. So it means from 40 to this line, I have just two lines. Okay, I have just two lines. So it means I'll take 40 plus those two lines is actually 12, since 6 times 2 is 12, then plus 12. So I have 52. So this point here is actually 52. So I'll come here, I'll write 52 comma, then I extrapolate to this other part here, which is 3.5, then plus 1 plus 0.1. So I have 3.6. So at the end of the day, I'm going to have 52 comma 3.6, and down here I'm going to have 262 comma 2.3. Okay, and with a negative slope. So it means this is actually my x2. No, this is my x2 here. This is my x2, my x2, my y2, and this is my x1 then my y1, or it depends on you. You can just flip it. Okay, but make sure that at the end of the day, your gradient should be negative. Okay, all right, so that is it. So I hope it is clear. And again, you all know on YouTube, I don't think there are people doing this data analysis stuff on YouTube, plotting graph, answering past GCE exams on data analysis. So I recommend share this video to your friends. It is very helpful. And also stay tuned for more data analysis videos. Okay, all right, so let's continue. Let's go and calculate our gradient knowing this point, knowing this point here. Okay, so we all know that gradient is actually changing this value over changing this other value here. Okay, so that is it. All right. Okay, so let's move now to the B part of the question. The B part says use your graph to determine the values of I naught and beta. Okay, so this part is very important. I think this part is about 8 marks here. Yeah, it's 8 marks. All right, so how are we going to do this? So for us to have these values, it means we have to calculate our slope. Okay, so our slope, as I earlier said, it is change. The change means the upper value minus the lower value divided by the upper value minus the lower value. Okay, so if I do my change, I'll have from the graph, right, I'll have 3.6 minus 2.3 divided by 52 minus 262. Okay, why like this? Because the line is actually at the end of the day, we are going to have a negative gradient. Okay, a negative slope. Okay, so if I do this, I'm going to come out with these values, and at the end of the day, I'm going to have that my slope is just equal to negative 6.2 times 10 to the minus 3 now per second. Why is it per second actually? So let's come back here. So from here, right, if you are taking a lien of a quantity, or if you are taking a lien of a quantity, it means the unit disappears. Okay, so here we have seconds. So at the end of the day, we are going to have per second, since the time is below this time is below. Okay, it's below this division sign. So that is why we have our slope negative 6.2 times 10 to the minus 3 per second. Okay, so that is it. Now we know that this is our slope, right? But from this our equation, from our linearized equation, right, we have ln I being equal to negative 1 over beta times t plus ln I naught. Okay, so this is actually this slope that you calculated, right, it is just equal to this value here, which is negative 1 over beta. So it means at the end of the day, we are going to have that negative 1 over beta is just equal to our slope. But what do we know about our slope? Our slope is this value here. So it means we are going to equate this negative 1 over beta being equal to this value here. This value here. Okay. So at the end of the day, we are going to have negative 1 over beta equal to 1.6 6.2 times 10 to the minus 3. Okay, so for me I can just cross multiply. Okay, so if you cross multiply, we are going to have negative 1 being equal to negative 6.2 times 10 to the 3, then times beta. Okay, so we can divide now all through by this quantity such that we are going to have negative 1 divided by negative of this value being equal to beta. Okay, so that we will just have that our beta is just equal to 161.5 seconds. Okay, why is this seconds now? Okay, we know that our slope was per second, so it means that if this value now comes again in the denominator, this per second will cancel the other per second. Okay, so I think yeah, yes, that is it. Okay, because if it comes, if this value is still coming back in the denominator again, it means it's going to be seconds, not per second again. Okay, so that is it. So this is our value of beta. Now we are to obtain our value of I naught. Okay, so what is actually now our value of I naught? So our I naught now is since our graph, right, our graph didn't begin from 0. Note, our graph did not begin from 0, so we cannot conveniently read the value of I naught. Okay, so it means we are going to use some trick here for us to solve for I naught. Okay, so from this our equation, right, from this our linearized equation, right, we can use a point that we use to calculate the slope. So we can choose 2 points that we use to calculate the slope. Let me say I can choose 3.6 and 5.2 because 52, because these two values, right, were in the same position. Okay, so if I choose these two values, it means I can conveniently calculate my lin I naught. Okay, how? So if this is my lin of I on in microamperes, right, here was supposed to be a slash here. So if this is my lin, it means I will use this value here. Since I'm using these two values, right, it means I will use this 36, and then my slope, which is negative 1 over beta, is just equal to this value here. Okay, this value here. And then my t, I'm going to use one of my t, which is 52. Okay, and then plus ln I naught. Okay, so at the end of the day, I'm going to have that 36. So this is it here, using 2 points to calculate the slope. Okay, so we have 52 comma 36 3.6. Okay, so at the end of the day, I'm going to have 3.6 being equal to negative of, because this place here was actually negative, and the slope alone, this just the negative 1 over beta also gave us negative. Okay, so that is why we have 3.6 being equal to negative of this value, then times 52, which is our time value. Okay, then plus ln I naught. Okay, so this negative will multiply with this other, we combine with this other one to give us positive. So at the end of the day, I'm going to have 3.6 being equal to 0.32 plus ln I naught. Okay, so if I take this other part, this other man, this other side, I'm going to have ln I naught being equal to 3.28. Okay, now from here, right, you are going to apply indices. Okay, so indices, if we are dealing with ln, it means we take e. Okay, we take e of both sides. Okay, it means we take e this side and then we take e this other side too. So that if you take e this side, the e will cancel with this other linear for it to be level 1, and then we take e this side. We are going to have that our I naught is just equals to e raised to the power all this answer. So at the end of the day, our I naught is just going to give us 26.6 microamperes, because I work with my graph using microamperes. Okay, all right. So generally, I think you when you are given a quantity, right, it will be better for you to convert it rather than working with it like that. Okay, so this is my value of ln I naught. So if you, as I earlier said, I'll leave that part as an assignment, that you are going to convert these microamperes to amperes, then you plot the graph, so you see that the values will actually slide. Okay, like there will be a somehow, let me say, we might have 30 point or 40 point. Okay, so this is my own value here using microamperes. Okay, without converting the column. All right, so what next? So from here, right, it means that my I naught is equal to 26.6, sorry, it was supposed to be microampere, not micro, and then my beta is just equal to 161.5 seconds. Okay, so the last part says what is the physical significance of beta. So from the equation given, beta represents the time constant of the capacitor. So assignment 2 says define time constant. So I'm waiting for a solution either in a general WhatsApp forum where you can access a resource that I've created, that you can access past papers, past A level papers, and past ordinary level papers. Okay, with no premium, which is not premiumized or whatsoever. Okay, so guys, you can actually follow us via this Mathematics Dreamland for Africa on YouTube. Sorry, here was supposed to be an A there. But anyways, I've just corrected the logo. Okay, so thank you guys for watching. See you in the next video. Please stay tuned for more data analysis video, A level physics. See you guys.